So in this video we're going to be looking at how to take the derivatives of inverse functions. So let's start with this. We remember that the f inverse of an original function is just equal to x, right? We learned that in algebra. But in a couple videos ago we learned that implicit differentiation lets us take the derivative of both sides of the equation. And what we're looking for is the derivative of that f inverse. So what that'll give us is f inverse prime of f of x, and then don't forget we need to have use chain rule here where we take the derivative of the inside as well and multiply it. So we have f prime of x, and then the derivative of the right side is just 1. So that'll give us that f inverse prime of f of x is simply equal to 1 divided by the original function's derivative, so 1 over f prime of x. Okay, so keep that in mind, but also remember that if we take f of f inverse of x, so if we take the composite function in either direction, it'll also give us x. So let's go ahead and take this derivative, and we'll get that f prime of f inverse of x times f inverse prime of x is equal to 1 as well. Alright, and then here we're looking for f inverse prime of x, so we'll go ahead and isolate that. That's equal to 1 divided by f prime of f inverse of x. Okay, so let's go ahead and keep those two things in mind as we move on to an example. So let's drop this example down here. Let's say we wanted to have a function f of x equals x squared, and we want to find the derivative of its inverse function. So we want to find we both want to find f inverse of f of x and f inverse of x. Okay, so first let's find the inverse. You remember in algebra what we do is we say y equals x squared, and then we switch the two, x equals y squared, and then that will give us that y equals the square root of x. Now keep in mind y was always positive in this first function, and we'll need to keep it consistent over here. So we have that this is for x is greater than or equal to 0. If we have negative numbers, we start to get unreal answers, and it simply doesn't work. So this is our f inverse. So f inverse of x is equal to the square root of x. Okay, now so if we wanted to find f inverse prime of f of x, that means we also need to find the derivative of the original function. So f prime, keep doing that. All right, f prime of x is just equal to, using power rule, it's equal to 2x. Therefore, f inverse prime of f of x is equal to 1 over, it's just equal to 1 over 2x. Nice. So also we wanted to find f inverse of x itself, which is equal to 1 over f prime of f inverse of x, and we already found that f inverse of x is square root of x. So we have f inverse, and that's supposed to be prime, f inverse prime of x is equal to 1 divided by 2 times and the parameter, the argument in the argument in this equation is f inverse of x, and f inverse of x is square root of x, so we have 2 times square root of x. Okay, and those are answers. Okay, so now that we have that down, let's go ahead and look at how we might be able to take the derivatives of the inverse trig functions. So I'm gonna move over here and we'll look at that. So let's start with the example of sine inverse of x. Okay, so y equals sine inverse of x. Alright, now we can rearrange this. We don't know what the derivative of sine inverse of x is, but we can rearrange this to say that the sine of y is equal to x. Now, I always like to draw a picture here. It just helps visualize it. If the sine of y is equal to x, that means the sine of this triangle is x over 1. That makes this angle y, and the bottom is 1 minus x squared. Okay, well, I want to know what the derivative of y is, or the derivative of sine inverse. So what I'm going to do is, because I know that my implicit differentiation is going to give me a dy a dx out of here, I'm going to go ahead and implicitly differentiate this equation. Okay, so what that'll give me is cosine of y times dy over dx is equal to 1. That gives me that dy over dx, if I divide the cosine on both sides, that'll give me secant of y. And if you look at our triangle up here, the secant of y is equal to the cosine is adjacent over hypotenuse, so 1 over the cosine, or the secant of y, is 1 over the adjacent side. So y prime is equal to 1 over the square root of 1 minus x squared. Okay? And this is why I liked to do, I wanted to do implicit differentiation first, because it makes this a whole lot nicer to explain if you understand that you can differentiate both sides of the equation using, product and chain rule to get the derivative of y out of this equation. Okay, so that gives us the sine inverse of x, the derivative of sine inverse of x, is equal to 1 over the square root of 1 minus x squared. Now, we could do this for all of the inverse trig functions, but I'm going to go ahead and just give you a couple of the main ones. So let's see, we have cosine inverse, and let's see, scroll down here a little bit. So cosine inverse, the derivative of cosine inverse of x is equal to, let's see here, negative 1 over the square root of 1 minus x squared. Let's do tan inverse, the derivative of tan inverse of x is equal to, I believe it's 1 over x squared plus 1. Then we have secant inverse and cosecant inverse. Let's go ahead and just stick with secant for now. And you guys can go find the rest of these later on your own if you would like to try it, but we'll go ahead and just write down secant inverse. These are all the important ones. I don't think that we normally use cosine a whole lot, just because it's the negative. We don't really use cosine a whole lot. It's just the negative of sine, but I am going to give you the rest of these. So secant inverse is equal to 1 divided by x times the square root of x squared minus 1. Okay, and these are important. I remember when I was taking Cal 1, I wished I had memorized these. You're supposed to. You really should memorize these because it comes in handy in calculus too. So I'll go ahead and just start those for you. These derivatives you're going to want to memorize, and what might help you out is if you go through and actually work out all of the derivatives for these, and that'll give you a better understanding of how they work. Also, after you maybe work out those problems, go ahead and go work a few homework problems from the OpenStax book. I believe this is chapter 3 still. We're on like 3.7, 3.8. Work some problems in there and get some practice. And we'll see you in the next video.